So before the screen comes on, the main purpose of doing queue counting is very relevant to a lot of agencies from banks, particularly retail, FMCG, retail outlets, because they want to be able to do some kind of analytics on the flow of their queues, such that they can like deploy more staff towards POSs or to basically increase the throughput for whatever reason that could possibly be causing it to be slow. Say, for example, maybe POS 1 has some delay in the way that it processes transactions, or maybe POS 2, but POS 2 doesn't, right? So then they can look at how they could possibly make the counter 1 run faster, or maybe it could be due to some kind of a human issue where the training for the person at POS 1 is not as good as a person on POS 2. So for whatever business reasons that could be, the purpose of this solution is so as to gather relevant data for them to even begin analyzing this kind of information. So what I'm showing here now on the screen is an example of how we gather this data. Because there's only just me in this live stream, right, and it's not so illustrative, I'm going to go into a video where we can see much more people. Okay. Let's exit this. Okay, so as we saw earlier, here in this screen, we have separated the screen into 4 quadrants. The top left quadrant is representative of, it is representative of counter 1, counter 2 for the top right quadrant. Bottom left quadrant is to represent Q1, bottom right quadrant is to represent Q2. Okay. And what we have here, we can see in this frame, the bottom here is showing Q1 has a count of 14 people, Q2 has a count of 7 people, counter 1, 11, counter 2, 9. In this case here, for this particular example, we are using the top left corner as the count within the individual quadrants. So we can select any other point of interest. It could be the center of the detection box, right? Okay, so this is what we have here as a summary for this single frame. Then here we have this running time series where we can see in Q1 there are 14 people at this time, and the source is from Q1's camera. You can see it matches up to this. Q1 has 14 people. And here, for example, if the Q is greater than 5, it will send an alert via WhatsApp or however we wish to decide, or however the customer wishes to decide to receive the alert in. And then they can send a supervisor to attend to that particular POS that is serving Q1. Okay. And then at the bottom here, what we have plotted here is a real-time time series plot where you can see as time changes, the queue length changes accordingly. Okay. So let me just play this to illustrate. Okay. You can see the queue length has changed for Q1, and we can change to different queues or different quadrants. So counter 1, counter 2. Yeah. And what I'm doing here is to change the alert threshold such that if the alert is different, we have the alerts being sent out based on the threshold. Okay. So if we change the threshold to 100, only if the queue is above 100 do we send an alert. And we can see that rightly, there are no alerts being sent. Okay. And similarly, if we reduce the alerts to a small amount, like 3, then we get the alerts being sent again. So the purpose of this tool is not so much the solution here, but rather the data that we obtain from this, such that the business user can start to look at how they could design the flow of their traffic a bit better. Okay. Are there any questions? Okay, if not, I'll hand it back to Alim.